In this video, we'll talk about how to get logistic regression to work for multi-class classification problems. And in particular, I want to tell you about an algorithm called one versus all classification. What's a multi-class classification problem? Here are some examples. Let's say you want a learning algorithm to automatically put your email into different folders or to automatically tag your emails. So you might have different folders or different tags for work email, email from your friends, email from your family, and emails about your hobby. And so here we have a classification problem with 4 classes, which we might assign the numbers, the classes y equals 1, y equals 2, y equals 3, and y equals 4 to. And another example, for medical diagnosis, if a patient comes into your office with maybe a stuffy nose, the possible diagnoses could be that they're not ill, maybe that's y equals 1, or they have a cold, 2, or they have a flu. And third and final example, if you are using machine learning to classify the weather, maybe you want to decide if the weather is sunny, cloudy, rainy, or snow, or if it's going to be snow. And so in all of these examples, y can take on a small number of discrete values, maybe 1 to 3, 1 to 4, and so on. And these are multi-class classification problems. And by the way, it doesn't really matter whether we index this as 0, 1, 2, 3, or as 1, 2, 3, 4. I tend to index my classes starting from 1 rather than starting from 0, but either way works, and it really doesn't matter. Whereas previously, for a binary classification problem, our data sets look like this. For a multi-class classification problem, our data sets may look like this, where here I'm using 3 different symbols to represent our 3 classes. So the question is, given a data set with 3 classes, where this is an example of one class, that's an example of a different class, and that's an example of yet a third class, how do we get a learning algorithm to work for the setting? We already know how to do binary classification. Using logistic regression, we know how to, maybe fit a straight line to separate the positive and negative classes. Using an idea called one versus all classification, we can then take this and make it work for multi-class classification as well. Here's how one versus all classification works, and this is also sometimes called one versus rest. Let's say we have a training set like that shown on the left, where we have 3 classes. So if y equals 1, we denote that with a triangle. If y equals 2, the square. And if y equals 3, then the cross. What we're going to do is take our training set and turn this into 3 separate binary classification problems. So turn this into 3 separate 2-class classification problems. So let's start with class 1, which is a triangle. We're going to essentially create a new sort of fake training set where classes 2 and 3 get assigned to the negative class, and class 1 gets assigned to the positive class. We're going to create a new training set, like that shown on the right, and we're going to fit a classifier, which I'm going to call h subscript theta superscript 1 of x, where here the triangles are the positive examples and the circles are the negative examples. So think of the triangles being assigned the value of 1 and the circles the value of 0. And we're just going to train a standard logistic regression classifier, and maybe that will give us a decision boundary that looks like that. Okay. This superscript 1 here stands for class 1, so we're doing this for the triangles of the first class. Next, we do the same thing for class 2. We're going to take the squares and assign the squares as the positive class and assign everything else, the triangles and the crosses, as the negative class. And then we fit a second logistic regression classifier. We'll call this h of x superscript 2, where the superscript 2 denotes that we're now doing this, treating the square class as the positive class, and maybe we get the classifier like that. And finally, we do the same thing for the third class and fit a third classifier, h superscript 3 of x, and maybe this will give us a decision boundary or give us a classifier that separates the positive and negative examples like that. So to summarize, what we've done is we've fit 3 classifiers. So for I equals 1, 2, 3, we've fit a classifier h superscript I subscript theta of x that's trying to estimate what is the probability that y is equal to class I given x and parameterized by theta, right? So in the first instance, for this first one up here, this classifier was learning to recognize the triangles. So it's thinking of the triangles as a positive class. So h superscript 1 is essentially trying to estimate what is the probability that the y is equal to 1 given x and parameterized by theta. And similarly, this is treating the square class as a positive class, and so it's trying to estimate the probability that y is equal to 2 and so on. So we now have 3 classifiers, each of which was trained to recognize one of the 3 classes. Just to summarize, what we've done is we want to train a logistic regression classifier, h superscript I of x for each class I to predict the probability that y is equal to I. Finally, to make a prediction, when we're given a new input x and we want to make a prediction, what we do is we just run all, let's say run all 3 of our classifiers on the input x, and we then pick the class I that maximizes the 3. So we just basically pick the classifier, pick whichever one of the 3 classifiers is most confident or sort of most enthusiastically says that it thinks it has the right class. So whichever value of I gives us the highest probability, we then predict y to be that value. So that's it for multi-class classification and one versus all method. And with this little method, you can now take the logistic regression classifier and make it work on multi-class classification problems as well.